Hello friends, welcome to Learner's Planet. Friends, in this session we are going to take some more problems based on reasoning, some more questions based on reasoning, some more puzzles we will be taking. And I'm sure you are having your paper and pen with you, so you will solve the problems right with me. Okay, so let's begin this session. Now friends, let's start this problem, a problem based on circular arrangement. Here, 6 persons are there. So first of all, we draw a circle for 6 people. Okay. Now, there are some males and some females in the circle, and white, black, blue, pink, red, and violet. 6 color of flowers are there. And okay. F likes pink, but pink rose, but he doesn't sit between A and D. I suppose F is here, and he, that means he is male and color is pink, right? So one position is fixed for F, male, and he likes color pink. Now C is sitting in front of D. That means CD may be this position, maybe this position, right? Let's see. C is sitting in front of D who like violet rose. Okay. There is one person sitting between F and female who likes violet rose. C is on the immediate left of F. Okay, C is here and C is sitting in front of D. That means D is here, right? Now there is one person sitting between F and female who likes violet rose. And here it is mentioned that C is sitting in front of D who likes violet rose. So this is violet and that is female. That means D is female, likes violet rose. After that, A is a female sitting between two males C and B. C here, that means B must be here, that should be male. C is also male, A is female, right? And who is immediate right of D, that's okay. The female who likes white rose is sitting in front of male who likes black rose. Only blue like B like blue rose, so B blue, right? And now only E is left, so he should be, or he or she should be at this position. Now female who likes white rose, that means we are clear that this is female, so it's white, and in front of a male who like black rose, right? So here 1, 2, 3 and 4. 4 are males, 2 are females, right? Now let's answer the questions. Now let's answer the 5 question quickly. Who is sitting in front of A? E. How many females are there? 2. Who is sitting on the third to the right of D? 1, 2, 3. C. Which two are sitting adjacent to each other in the circle? C and F? Yes. A and E? A and E? No. B and D? Yes. Both 1 and 3. Okay, so this is the correct answer. Who likes a white rose? So that's A. Okay, all the question we answered in just 20 seconds. Once the arrangement is clear, after that there is no problem. Okay, I hope you are clear. Now this problem, setting arrangement as well as relationship, blood relationships. In a family of 8 members, this are facing north. Okay, so first of all let's draw the 8 positions. 1, 2, 3, 4, 5, 6, 7 and 8, right? Now 2 females are sitting at the extreme corner. Female on the extreme left end is the daughter of female who is sitting on the right end. So here it's female and she is daughter and she is mother. Okay. Now then, Shyam is grandfather of Pankaj and sitting between Deepika and Pankaj from the left end. Okay, so let's see. Bhakti is mother-in-law of Prerna and sitting second right of Prerna. Swati, who is on immediate right of Prerna, is daughter of Ajay's brother. Okay, it seems this must be Prerna. Let's have a guess. This is Prerna, and if she is mother, this is daughter, and then we proceed. Bhakti is mother-in-law of Prerna and sitting second right from Prerna. So Bhakti must be here, right? And Gaurav, who is married to Prerna, is fourth from the end. So left hand 1, 2, 3, 4. That means this must be Gaurav. Mother of Ajay is sitting between Ajay and Swati. So this must be Ajay's mother because that is the second generation, and this is Gaurav. So this is Ajay and this is Swati. After that, okay, Shyam is grandfather of Pankaj and is sitting between Deepika and Pankaj. So now we have two positions for Pankaj and Shyam. So it must be Shyam, it must be Pankaj, and she must be Deepika. Okay. Now this arrangement seems to be correct. Now we have to find out the relationship. Now Prerna is daughter of Ajay's brother. Now Ajay and Gaurav, they are brother, and Bhakti and Shyam, this seems to be husband-wife. Bhakti, Shyam, husband-wife. Then in this generation, Gaurav and Ajay is there. Then Gaurav is married to Prerna, so Gaurav and Prerna married. Prerna is mother of Deepika, and Swati is daughter of Ajay's brother. So Swati is also daughter of Gaurav. So Swati, then Deepika, and one more person, Pankaj is there. That is his grandson of Shyam. So Pankaj is also in the same generation. Now let's try the questions and see what happens. Now let's answer the questions quickly. How many children does Prerna have? So Prerna is second generation. So Prerna must have Swati as daughter and this Deepika as daughter. Pankaj is actually grandson of Shyam and Bhakti, but he may be son of Ajay also. But there is no mention of Ajay's wife, so Pankaj must be son of Gaurav only. So Prerna and Gaurav must be having three children, that is Swati, Deepika and Pankaj. Okay. How is Deepika related to Bhakti? Now Deepika and Bhakti. Bhakti is here, Deepika is here. So Bhakti must be grandmother of Deepika. Okay, so that's granddaughter. Which of the following pair shows a married couple? So married couple is Gaurav Prerna, that's true. No other, so only Gaurav Prerna. What is the position of Ajay with respect to his father? Now Ajay is here and Shyam is here, right? So it's third to the right. Okay. Now since they are facing north, so we have to assume it to be third to the left. This and this. Okay, facing this side, that means third to the left. Who is on the extreme left end? Extreme left is Deepika. Okay. So bit hit and trial is definitely involved, but once you are able to crack all the positions, all the relationships, then answering the 5 questions will be very easy. It will not take more than 30 to 40 seconds in answering all the questions. Okay, I hope you are getting it. Now friends, I would like to discuss over here the problems based on cutting of a cube. Now what exactly the pattern of problem, that is here I have taken one example. What is the maximum number of identical pieces a cube can be cut into by 4 cuts? Right, now how could we make the cuts? I just show you one example over here. This is a cube I am having. Now I have shown over here how can we cut a cube. So this is this way, that means the complete cut will be there. this is this way, the complete cut will be there, and after that the third cut, that will be horizontally, right? So the entire cube by this cut will be converted into two cuboids. Okay, getting my point? So what exactly is happening if we make this 3 cut? What is happening? See this, the cube is cut into half, further half, that means 1/4, that means 4 pieces we have got, and if we make this cut, this 4 pieces will be converted to 8 pieces, right? So with 3 cuts we can get 8 identical pieces. Okay, so these sort of questions are frequently asked in reasoning based examinations. Now the important thing that over here that you have to keep in your mind, see, one cut make 2 parts. Obviously this one cut is there and that is making 2 parts. Again one cut is making 2 parts. That means 2 cuts are making 4 parts. Okay, it's not that directly double, it is actually number of cuts plus 1, right? If there are 2 cuts, it will make 3 parts. If there are 3 cuts, it will make 4 parts. Okay, it's not at all double. So that's the important thing, right? So number of cuts, number of parts will be 1 more than cuts. Number of parts is equal to 1 plus number of cuts. Okay. Now I introduce the 3 types of cuts. We can name them. This is vertical cut, this is horizontal cut, and this is you can say final cut, right? So horizontal cut plus vertical cut plus final cut, right? These sum is fixed. Particularly in this case, suppose I talk about these 3 is sums as 4, right? That means this cut plus this cut plus this cut must be equal to 4, right? Now we have to find out the maximum number of pieces by making 4 cuts, right? So there are not much possibility. I can take 1 horizontal plus 1 vertical and 2 final, right? 2 final, that means 2 cuts like this. Or I can interchange the this number also, doesn't matter. If I make 1 cut, 2 parts will be there, into 1 cut, 2 parts will be there. If I make 2 cuts, 3 parts will be there, right? This is sum of cuts, this is number of parts. So 3 2s are 6, 2s are 12. So in all there will be 12 parts, right? So it's so easy to calculate. Okay, I take the next example. Listen to me carefully. Some more logics are involved in this sort of question, so just listen to me carefully. Now, what is the maximum number of identical pieces a cube can be cut into by 13 cuts? That means horizontal plus vertical plus final, that must be 13, right? Now what we have to do, we have to find out the maximum number of identical pieces. For that, the product of part 1 into part 2 into part 3, right? From H we are getting parts, maybe part 1, this is part 2 and this is part 3. So that should be maximum, right? Now an important logic is involved over here. Just listen to me carefully. This product will be maximum if difference among H, B and F is minimum, right? I give you various examples. See, H, B and F is 13, right? So we have to keep the differences minimum. So what are the options? That is 5, 5 and say 3. Okay, this is one equation that will give you 13. The other is 4, 4, 8 and 5, right? So maybe this equation or this equation. In both the cases, the sum is 13. Listen to me carefully. 5 plus 5 plus 3 is 13. 4 plus 4 plus 5 is 13. Right? Now, here the difference is more, here the difference is less, right? So you are going to get definitely maximum product in this case. You can practically see it, right? From 5 horizontal piece, you'll be getting 6 part, again 6 and then 4, right? So from these pieces, that is H plus V plus H and V and F, you are getting these many parts. So 6 6 are 36, 36 into 4 is 144. Okay, now this if H, B and F is these, maybe in this any order, doesn't matter. From 4 pieces you'll be getting 5 parts, then 5 parts and then 6 parts. So 6 5s are 30 into 5, 150, right? So maximum parts is this, 150 will be the correct choice. So minimum difference will produce maximum product. Okay, So that's 150 is the answer for this particular question. Okay, I hope you are getting me. Now, what is the maximum number of identical pieces in which a cube can be divided by 12 cuts? So, horizontal plus vertical plus final is 12, right? Now, as I have already told you in the previous question, that difference among these should be minimal. So, that's possible if we give them equal breakup, that is 4 and 4 and 4. 4, 4, 4. 4 horizontal cuts, 4 vertical cuts and 4 final cuts. Okay, so 4 horizontal, 5 pieces, 4 vertical, 5 pieces, 4 final, 5 pieces. So 5 into 5 into 5, 125 pieces can be obtained at max. Okay, no other breakup will make more number of pieces. Okay, because maximum product is 125. Getting my point? Minimum difference, here the difference is 0. Minimum difference will produce maximum product. In the previous case it was 13, so we took 4, 4 and 5. Order doesn't matter. The only thing that matters is the difference should be minimal. Okay. Similarly, if you have to make 14 cuts, then what will you do? 4, 5 and 5. That will produce the maximum number of identical pieces. In that case, 5 into 6 into 6. Okay. So in that case, 6 into 5, 30 into 6, 180 pieces will be obtained with 14 cuts. Okay, these are the maximum number. Okay, so I hope you are getting my point. Give the minimum difference to get the maximum product. And why it is happening, I put up an example. See, suppose I have two numbers, x plus y, their sum is say 8. Right? Now, maximum product of x and y. When you want x, y, product max, then what will you do? See, if I give them the breakup as 3 and 5, then product will be 15. If I give them the breakup as 4 and 4, then the product will be 16, right? Minimal difference, maximum product. More difference, less product. Okay, if you give 1 and 7, then the product will be 7 only, right? Because more the difference, less the product. The same funda I'm using over here. So you should be conceptually, logically clear with the this pattern of problems. Okay. Now this question, what is the least number of cuts required to cut a cube into 24 identical pieces? That means part 1 into part 2 into part 3 is 24, right? So 24 product can be achieved by 1 into 12 into 2, or we can achieve it by 2 into 2, 4 into 6, right? This way, or maybe 2 into 3 into 4, right? So minimum difference is over here, right? So in this case we are getting 24 pieces, right? Now two parts, that means 1 cut. 3 parts, that means 2 cut. 4 parts, that means 3 cut. So 3, 4, 5 and 6 cuts. So 6 are the minimum cuts which are required to make 24 identical pieces. Isn't it very easy? See, in this case 6 cuts are there. If we see this, so it will be 1 plus 5, right? For 6 parts, 5 cuts. So 5, 6 and 7 more cuts are there, right? So with minimal number of cuts, we are getting 24 pieces when the number of cuts are 6. Okay, so you might have understood the difference. When the difference among the numbers is minimum, you get the maximum product. Okay. Let's take the next one. Now, what is the least number of cuts required to divide a cube into 120 identical pieces? That means P1 into P2 into P3 is 120, right? By hit and trial, if we say 3 into 4, 4 threes are 12 into 10. No difference is very much. Now instead we are having 10 here. If I take 2 from here and shift it over there, what I'll be getting? 6 into 4 into 5. Now the difference is minimum among the numbers, right? So in this case we'll be getting the product as 120. Now let's count the number of cuts. 6 parts, 5 cuts, 4 parts, 3 cuts, 5 parts, 4 cuts. So 5 and 3, 8 plus 4. In all it is 12 cuts. Okay. So isn't it very easy? Let's take the next one. Now see this. A cube is cut parallel to one face by making 10 cuts such that all of resulting pieces are identical. What is the maximum number of identical pieces that can be obtained by now making 2 more cuts? Okay, 10 cuts are already there. Maybe this way, doesn't matter for us. Now we are to make 2 more cuts, right? So 10, suppose these are horizontal. Now we are left with vertical and final, right? Now we have two options. Either one of them is 0 and other is 2, or maybe 1 and 1, right? If one of them is 2 and other is 0, then what will be getting? 11, 3 and 1. 33 pieces. And instead, if one of them is 1 and other is also 1, in that case 11, 2 and 2. Now the difference is minimum, so you are getting the product as maximum. 11 into 2, 22 and 2, 44. Right? So that would be better idea. Okay, I hope you are getting the idea behind these questions. Now let's see this question. What is the least number of identical cuboids, each of dimension this are required to form a cube? See friends, this is a cuboid. Maybe you can consider it like this. This is maybe 4, this is maybe 5, and height is suppose 2. Right? Now if you have to form a cube, what should be the condition? That means the height, length and width, all of the three should be same, and that is possible only when we take LCM of 2, 4 and 5, right? Then only we can make each and every face of the cube to be same, right? So what is LCM of 2, 4 and 5? That's 20, right? So that means each side of the cube that will be formed will be 20. 20 this, 20 this, and 20 is the height. Okay. So in this LCM we can fit up this 4 and 5, this 4 into 5 easily, right? This way, maybe this way, right? So we can fit. So that means volume of the cuboid that is being formed is 20 into 20 into 20, right? Now volume of cuboid is what? 2 into 4 into 5. So if volume of the cube divided by volume of the cuboid, then we will be getting number of cuboids required. So that's 200. Pretty simple. Okay. So friends, in the next session we'll be taking more problems based on reasoning. We'll be solving more puzzles. So do revise this session and the previous ones. I'll see you in the next session once again. Bye bye.